Hello, this is not your chem tutor, and in this video, I will teach you how to convert molality to mass percent and vice versa. Before you continue this video, make sure you already know or you are familiar with the concepts of mass percent and molality. If not, then don't worry, I made separate videos and you can check those videos using the links I put on the description box. As usual, I included examples in this video so we can practice some calculations. Let's have a quick recap about mass percent and molality. Mass percent is also known as percent by mass or weight percent or percent by weight, or you can see symbols like percent M over M or percent W over W. The formula for mass percent is mass of solute divided by mass of solution times 100. Now, what does percent mean? When you say percent, cent means 100. So percent means per 100. So when you say mass percent, this means per 100 grams of solution. For example, if you are given 25% by mass, that means 25 grams of solute per 100 grams of solution. Another example, say you are given 10% by mass. This means 10 grams of solute per 100 grams of solution. So that's how you interpret mass percent. Now let's move on to molality. The formula for molality is moles of solute per kilogram of solvent. So the unit for molality is moles per kilogram, or this is also known as molal. And the symbol for molal is lowercase m. So how do we interpret molality? So say for example, you are given 5.0 molal. This is equivalent to 5 moles per 1 kilogram of solvent. So 5 moles of solute per 1 kilogram of solvent. Another example, say you are given 2.5 molal. This means 2.5 moles of solute per 1 kilogram of solvent. So this is how you interpret mass percent and molality. Please take note of this because we will be using this in answering our examples. Just a quick reminder, you need the molar mass of the solute to convert molality to mass percent and vice versa. Sometimes professors give the molar mass in the problem, but sometimes they don't. If in case they don't give you the molar mass, you need to solve it on your own. If you still don't know how to solve the molar mass, don't worry, I made a separate video and you can check that using the link on the description box. Another thing, please remember that mass of solution is equal to the mass of solute plus the mass of the solvent. We will need this to solve our problems. Let's try example 1. The concentration of glucose in a solution is 12% by mass. What is the molar concentration of glucose? So we are given 12% by mass, and we will convert this to molality. We just learned a while ago that 12% by mass can be expressed as 12 grams of solute, in this case glucose, per 100 grams of solution. Step 1 is to solve for the moles of glucose. So we have 12 grams of glucose, and we are given the molar mass of glucose, which is 180.156 grams per mole. So 12 grams, 1 mole of glucose is equivalent to 180.156 grams. So grams will cancel out. We now have moles as the unit. So 12 times 1 divided by 180.156, this is equal to 0.0666 moles of glucose. Step 2 is to solve for the mass of solvent. We know that mass of solution is equal to mass of solute plus mass of solvent. The mass of solution is 100 grams. The mass of solute again is 12 grams of glucose. So to get the mass of solvent, you will transfer 12 grams to the left side and it becomes negative or minus. So 100 grams minus 12.0 grams, this is equal to the mass of the solvent. So mass of solvent is 88.0 grams. Now that you have the mass of solvent, we can do our final step. Step 3 is to solve for molality. So we will be using this formula. So molality is equal to the moles of solute, which we got in step 1, 0.0666 moles divided by kilogram of solvent. So in step 2, we got grams of solvent, which is 88 grams. To convert grams to kilograms, you just need to divide it by 1,000. So 88 divided by 1,000, that is 0.088 kilograms. So molality is equal to 0.0666 divided by 0.088, and that is equal to 0.757 mole per kilogram, or 0.757 molal. And this is the answer to the question. Let's try our next example. The concentration of acetic acid in a vinegar sample is 4.50 molal. What is the mass percent concentration of acetic acid? So in this problem, we are given 4.50 molal, and we will be converting this to percent by mass. As we just learned a while ago, you can express 4.50 molal as 4.50 moles of solute, in this case acetic acid, per 1 kilogram of solvent. Okay, let's proceed to step 1. Step 1 is to solve for the mass of solute. So we are given 4.50 moles of solute, and we are given the molar mass of the solute, which is 60.052 grams per mole. That means 1 mole of solute is 60.052 grams. So moles will cancel out. So we have 4.50 times 60.052. This is equal to 270.234 grams of solute. Step 2 is to solve for the mass of solution. So we know that mass of solution is equal to mass of solute plus mass of solvent. So mass of solution is equal to, in step 1, we solved the mass of the solute, which is 270.234 grams. So you put that 270.234 grams plus the mass of solvent. We are given 1 kilogram of solvent. To make the units consistent, we convert 1 kilogram to grams, and we know that 1 kilogram is equivalent to 1,000 grams. Therefore, the mass of solution is equal to 1,270.234 grams. And finally, step 3 is to solve for mass percent. So we will be using this formula above for mass percent. So mass percent is equal to the mass of solute, which we got in step 1, 270.234 grams, divided by mass of solution, which we got in step 2. So that's 1,270.234 grams times 100. And if you solve this in your calculator, the answer is equal to 21.3% by mass. And this is the answer to the question.